So we're going to finish up this little bit of the ionic compounds section by talking about hydrated ionic compounds. Some ionic compounds, as they crystallize from an aqueous solution, will incorporate a specific number of water molecules into their crystalline structure. So these are called hydrates because they contain water. When your body is hydrated, you have enough water in it, right? And when you are dehydrated, that means you don't have enough water. So we have hydrates. Oh, forgot to check out the pointer. There we go. We have hydrates. Here's cobalt 2 chloride. This one has 6 water molecules in its structure for every 1 formula unit. Here's the anhydrous version. An is a prefix that means without. So this is the without water version. This is just cobalt 2 chloride. The color is different. The molar mass is going to be different. If you dissolve them in water, then they're both going to act the same. So these are called hydrates, and we have to have a way to name them. So Epsom salts is another substance. That's the common name. That's something you can buy at the drugstore, put in your bathtub and soak your feet or whatever. Epsom salts, magnesium sulfate, heptahydrate. So we name the ionic portion the same as we name any other ionic compound. This is magnesium sulfate. Magnesium is in group 2. It doesn't need a Roman numeral. SO4 is sulfate. This dot is not a multiplication sign. Not a multiplication sign. You can't multiply molecules or ions or anything. It just says they are together, and then the 7 tells us there's 7 water molecules for every one of these. So to name this part, we'll use a numerical prefix, hepta, heptahydrate, meaning 7 water. COCl2, this is cobalt 2 chloride. Cobalt is not in groups 1A, 2A, 3A, zinc, or silver, so it needs a Roman numeral. Cobalt 2 chloride, and this has 6 water, so it's hexahydrate. These are the common hydrate prefixes, and other than hemi, which means half, the rest of them will also be used when we talk about molecular compounds. So we should be able to name hydrates and write formulas for hydrates. So let's look at this one, CaSO4 dot 1/2 H2O. First, name the ionic part. Calcium sulfate. So it's calcium. It doesn't need a Roman numeral, so it's just calcium. Sulfate. Oops. And the prefix for half is hemi, so hemihydrate. What is a hemisphere? It's half of a sphere, right? Okay, our Earth has 2 hemispheres. So hemihydrate is half a hydrate. Does that strike you as being odd? How can you have half a water molecule? Well, you can't. We write all of these hydrates using the formula unit for the ionic compound. And then this is giving us a ratio of how many water molecules are with that. So what this is really telling us is there are 2 calcium sulfate units for every 1 water molecule. But convention says we just need to use the regular ionic formula, and so that's why we end up with half for the H2O. What would this one be then? Calcium. Does it need a Roman numeral?
Yes.
No. Group 2A. Okay. Group 1A, 2A, 3A, zinc, and silver. No Roman numeral. So the reason, because we know what its charge is. So just calcium, chloride, and then what's the rest of it? Dihydrate. So 2 hydrates. So here's the name of a hydrate. Write the formula. Well, ionic compound, we need to look at the 2 ions present. So there's barium and there's hydroxide. How do we know what hydroxide is? It's OH minus. Why? Because that's what it is. You memorize it, right? What's the charge on a barium ion? 2 plus. Why? It's in group 2, right? All the group 2 metals have a +2 charge. So once we have the formulas with their charges, then we can see how many of each we need so that when we scrunch them all together, their charges add up to 0. We have a neutral compound. So however you think of it, you should end up with BaOH2. The OH needs parentheses because it's a polyatomic ion and we have more than one of them. Yeah, so SO4 doesn't have parentheses because there's only one unit. And Cl2, there's 2 of them, but it's not polyatomic. So there is reason behind this. And if you can keep working on it until you're like, oh, I see why they're doing this, then it actually becomes quite simple. But you got to push through to that point. How do we do octahydrate? Yeah, so we're going to put a dot here, 8 H2O. Any questions?